Hello, differential equation students, and welcome back to Unit 5, and this is section 6.3, and now we're on to video number 3, which is going to be over our second example. And this example here, as we're looking at it, I see that 3x is my a sub 2 of x. Set that equal to 0, I see that x equals 0. So that means all points are ordinary except for x equals 0. So in this case, because it's a singular one again, we're going to go about x equals 0. Okay. Which you kind of remember before. We took the time and we ended up plugging in, right, for like this. And we found those earlier, which I don't think this is overly difficult to plug in, so maybe I'll just get straight into it. That's a terrible summation sign here. So I have x equals, I'm sorry, this is the summation, figure it out here, summation of n equals 0 to infinity of, well, what was that before? That was c sub n times n plus r times n plus r minus 1, because this is the second derivative, right? This is x to the n plus r minus 2. And then out front was the 3x here. Then it's plus 7 times, well, times this y, right, which we know to be, now it just so happens that I see that I've misprinted this. This needs to be a y prime. Okay, that means as n equals 0 to infinity, I am doing, well, that would be c sub n of n plus r, x to the n plus r minus 1. And then I have this plus 2x times my y, which we know is the summation of n equals 0 to infinity of my c sub n x to the n plus r, right? So we have this example here, and hopefully that wasn't too bad. Now what we're going to need to do is we're going to need to distribute, of course, here maybe before I even move on, this is all equal to 0. Right? And now what I want to do is I want to go through and I want to distribute these terms, right? And if I distribute that in, what I'm going to find out is that this x is going to make this 2, right, this negative 2 into just a negative 1, and then this 3 I'll just place with that c sub n. So I have n equals 0 to infinity, 3 c sub n, n plus r minus 1, x to the n plus r minus 1. Then I have plus, of course, this 7 just gets pushed in there. N equals 0 to infinity, that's 7, c sub n, n plus r, x to the n plus r minus 1. Now I'm taking this in, right? And now when I do this, this is an x to the first, so I actually gain an x up there. So this is the summation of n equals 0 to infinity of 2 c sub n x to the n plus r plus 1. And that equals the 0 there. Now what we're going to run into is what we did last time too, is this n equals 0 and this n plus r minus 1 is going to give us a little bit of issues, because if I end up just letting the k value, or my k, right, if I let k equal n minus 1, then k plus 1 is equal to n, and if I take that k plus 1 and I plug it in over here, when I subtract I'll have a negative index, right? And that's a bad deal. Can't have that negative index there. So I have to try to alleviate that, and how I did it was just like I did in the last problem. I am simply going to figure out these n equals zeros. I am going to just calculate those, and then that'll bump the index up to 1. Now this one over here, I shouldn't have to worry about because it's got this plus 1, and if I let k equal n plus 1, then k minus 1 equals n, and when I plug a k minus 1 here, then that'll just be k equals 1, and I'm okay with that. Okay, so I don't have to worry about this one over here, but I do have to worry about the first two. So I have to find out n sub 0. Well, that'd be 3 c sub 0, then that's an r, and times r minus 1, and then that's x to the r minus 1. This one over here would be then plus 7 c naught, then that would be an r, and then that's, oh, okay, so I have this x minus 1 again, right? Which isn't so bad. I'm going to erase this just so I can write here. Then that's r, and then that's x to the r minus 1. Now, these are all now, they do have the same x to the power, and they do have the same index because now it's going to be bumped up to n equals 1. And I would have my 3 c sub n plus r, n plus r minus 1, plus 7 c sub n plus r, and then these all have that x to the n plus r minus 1. Okay, and remember, this is just these first two. I haven't even touched this last one over here. Okay, as I look at it now, I would like to get them all to be the same. And if I end up trying to calculate this, I need them all to be the same, like I said, but the question is, and I didn't need to erase that part, I need that back. That was n plus r minus 1. I need these powers, right? I need the power to actually be x to the k plus r. If I can get it to that, I feel pretty good. So what does that mean for this one? Well, that means that n would have to equal, or I'm sorry, not n, but k would have to equal n minus 1. So then that's k plus 1 would equal n, right? And then I'm substituting in over here. Of course, all this stuff over here is going to have to stay. And actually, now that I'm thinking about it, let's not even write it like that. What would be a smarter way to write it? Well, we know that these both share these x to the r minus 1, so maybe I'll just write it as 3 c naught r minus 1 plus 7 c naught r. And then I'm multiplying that by the x to the r minus 1 plus the summation of, okay, now I'm plugging this in over here, right, which makes k equal to 0 to infinity. And now I'm plugging that in, right? So if I plug that in, I should have my 3. This is c sub k plus 1 times my k plus 1 plus r times k plus 1 plus r minus 1 plus 7 c sub k plus 1, and then I have my k plus 1 plus r, and this is all multiplied by x to the k plus r. Okay. Of course, at this point, it might seem like it's extremely hard, but really, we're pretty close here. So from here, what I need to do is, that's just these two, right? Do I run into issues? This was n equals 0 before I erased it. do I run into issues if I let x, or not x, but k equal the n plus 1, right? Well, then that'd be k minus 1, or k plus 1 equals, no, it's k minus 1 because it was plus there, so this is k minus 1 equals n. Now when I plug it in over here, I think I'll be okay. So what that allows me to do then is I can just add, the summation will be k equals 1, and then I would have, well, it's up here, it's this 2 times my c sub k minus 1, and then that's x to the k plus r, right? Now we can see that we actually have made all of the, nope, I wanted a different color than that. So we can see that all of the x's match out now, right? Those two match, which is great, but what you can also see is that these don't match, right? And we've talked about this idea before too. When this happens, we can't have this k equals 0. We can't make this k equals 1 down to 0, but we can make this k equals 0 up to the k equals 1. And how we do it is I need this thing right here. I need the k equals 0 part. So when I do that, that's 3k plus 1, that's 0 plus 1, that's 3 c sub 1. Then it's 0, okay, well then that's just a r plus 1. Then I would have a 0, well these cancel out, right? So that's just an r, and I think I'll put it here out front, plus 7, that would be a c sub 1, and then I have my 0, that's r plus 1 then in there. Then this whole thing would have, well, if I plug in a 0 for k, that's just x to the r power, right? These technically would drop, but then what I'm allowed to do is I can write the summation k equals 1. Now, because it's k equals 1 to infinity for both of them technically now, right? That means I can plug them both in. Now when I do this, I think I'll group certain things together here. So I have a 3 times k plus r plus 1 times a k plus r, and then I have this thing over here, which is plus 7 times k plus r plus 1. Now these both have my c sub k plus 1. Okay, and then this thing would just be added on, so then it's plus 2 c sub k minus 1, and then all of these, right in here, let me see if I can move this. Okay, all of these now would have the x to the k plus r. This is great, fantastic stuff. Do not forget that this technically is down here and being added in too. Okay, and the whole thing is equal to 0, right? And what we're going to do now is we're going to play the matching game, and we're going to match some stuff up. These all, like this, has 0 on this, has 0x to the r minus 1, right? And this has also 0x to the r, and it also has 0x to the k plus r. So because all these are 0, we need to take these things that they're attached to and set them equal to 0 and try to do the matching of the coefficients like we've done before. I will be doing that, but you should try it out on your own first. In fact, I'm going to stop this video here, and we will pick it up right here on the next video.